G'day viewers, well I scored myself a radiogram from a garage sale. Been a bit weathered unfortunately. It's a HMV Bahama, but this one's kind of interesting because Bahama was only ever a portable, so it's a bit of a strange one, this one. I cleaned it up, freed up this turntable. It's an old BSR, it was all seized completely, nothing worked, but I fixed all that. Fixed the dial core because it broke while I was tuning it. The plastic wheel, the big gear, or the pulley for the tuning capacitor had brittled up in the middle and went cockeyed, and when I tuned it the dial cord jumped off, but I've since fixed that with some JB weld. This is supposed to be a brownish colour, like a brownish colour and tinted, so you can't see this behind it, but it's been weathered a bit, this one. But that was where the other previous owner had it. He got it at the garage sale years ago. It had been out in the weather for a little bit when he got it, so, and I bought it off him, which he did have plans to use it, but it sat in this shed, collected dust for about 15 years, so I said bugger it, just letting it go, he's moving, so now I've bought it. It does all work fine, it's all solid state. It's only got a small chassis about the size of there, sits in there. Solid state chassis with about 4 transistors on it, all Australian made. MSP manufacturer special products speakers made in Sydney, the 8-inch drivers. Very good sounding unit. Just got to clean up the cosmetics of it so it's all nice and looks good. So it all works very well. As for an update, we need Pope. It's going quite well. I did some topping up with JB weld. Those patch points, I didn't really like them. What I ended up doing, I found out those patch points, you can't actually solder that evaporator. And while I've used lead, which is a lead-based solder, I found it, I didn't quite trust it, so I just put some JB weld over them. I roughed them up a little bit and covered those patch points up with a nice good thick layer of JB weld. I was careful to rough it up and put JB weld over them. I do have faith in JB weld, it's good stuff. Because the previous, whoever did that repair, put resin over it, but that just peeled off, so I said bugger it. If that resin just peels off, it's not very bloody good, so I just put JB weld over it. And that's never going to come off. I made sure of that. But it's been very good. No problems with this. I've made up a label, cut the can, and used it as a refrigerant label. I found the schematic and stuck it back on. There we go, now it's compliant. I just got to put a flammability sticker on it and it's all compliant. But it works quite well. But this is a very well working fridge. It keeps time and everything. It does a little bit lose its time, but that's alright. It's a synchronous motor running off an inverter, not the grid, even though it's a pure sine wave inverter. Got it done for, and it keeps very nicely cold. It's cycled on and off like it should. Defrosts like it should. It's works very well actually. I did some buffing and some cut and polishing. Quiet compressor now. It's happy. But yeah, this thing works really well. I've set this up as my refrigerant fridge. This is my refrigerant storage fridge. Both these fridges work quite well. Got that one years ago at my previous workplace, and this now I got off Facebook Marketplace. They said it was out of gas, it didn't work, and pick it up scrap. So well, I cleaned it up and plugged it in and it worked fine. Got a fully frosted coil and everything. There's nothing wrong with it, but it's a good storage, I use it for storage. So I got my oil there, my refrigerant. So I got this universal bloody can adapter. I cut the top of valve of this off flush. There's a little moulding in there which allows one of these to press down and make a self-setting depressing valve. This thing seals nicely. Good conversion. So it worked out quite well. Happy with that. But I think it's come up quite nicely with the cut and polish. Even the badge is nice and shiny. I'm happy with how that worked out. Got the kilowatt meter on there. about 133 watts, not too bad at all. Anyway, doing some work on my little high chill project under the thermostat. Not quite calibrated because it starts the compressor up while it's still under head pressure and chips it out, so I've got to tweak it a little bit. I've redone my capillary tube because the idea of having a heat exchanger like this, you want to make it work as efficiently as possible. And yeah, having a heat exchanger makes a big difference of the overall efficiency of how it operates. Like I've done here, your capillary is stuck and soldered to the cold air return line, cold return line, suction line back to the compressor. And that acts as a heat exchanger. And that boosts the cooling effect, so to speak, and gets maximum efficiency you can possibly get out of your system. So I just chucked the hole on around it and stuck it in there like that. And then I let this all dry from frost so that the aluminium tape can stick to it. I'm going to wrap this all around here with aluminium tape. They get a really good heat exchanger effect. Yeah, this has to be tweaked a bit because it's just not starting the compressor once it's fully dumped its pressure. How I've designed it there, this thermostat's calibrated for a normal fridge, but how I've got this thing laid out, it's starting it up a little bit too soon before the pressure has a chance to equalise, and it's tripping the overload. Okay, well, not the prettiest looking thing, but it should work. Let's give it a try. Turn it on run. Lowest setting. The warmest setting, I should say. The heat exchanger is getting hot. That should be getting cooler. That capillary should be getting cooler now. The actual capillary overall is nice and cool. Yeah, the capillary is a bit warm, but they're taking the heat out of it with the cold, so that's good. Yeah, that boosts the cooling effect a little bit doing that. Ideally, hey, cycle it off, on. Yeah, this bag's not the most efficient thing either. I might have to go to Bunnings, get some foil board. Yeah, tried to start, it's tripped. I just tried to start the compressor under load. It does work. I have to make a foil board insulated cooling box. This is not very efficient at all. This doesn't hold cool very good at all. So that doesn't help either. But it works. Might try it on the higher setting, let it equalise. Oh, I'll have to calibrate this thermostat. I looked at some foil board at Bunnings, but you can only buy it in the massive bloody 2 by 1 metre sheets. You can't buy it in small quantities, you have to buy a whole big sheet, which is a tool I need to do my shed or something, or insulate the whole shed. I'll buy it, but I just don't need to buy that much of it. Might have a little styrene box or styrene packaging would work. This really needs to be calibrated. The only part of this has to be calibrated. Too much thermal mass in this now. Alright. That's quite hot. Just put a fan on that. The capillary tube's got too much thermal mass. Yeah, that's warm there. No, this isn't working too officially at all. It was getting really cold, but my heat exchanger, I got too much thermal mass, more than what cooling it's putting out, so terribly inefficient. It might even be the way I charge the system too, because although it was getting, well, it's nice and cold, my feet are cold. The although I put enough charge in there, it's getting cooler back here, but then it starts getting too hot back into the compressor, so I might have play around with the charge, how much I'm putting in there. This isn't the most efficient system, but it does work. But for it to work properly, I should replace this with a proper condenser with a fan. I'll wrap my capillary around here most of the way to get the best possible performance out of this thing. Not the best performer, but it does work. So I might have to experiment with this to make it a proper functioning drink chiller. For it to work properly and reliably, I have to go back to the drawing board with this one. Yeah, it's quite hot, that compressor. Not dangerously hot, but more hotter than what it should be. These are good compressors though, these are Embarcos. They're a nice unit. Anyway, and carbonator is going quite nicely. As you can see, I've got some water there, and it's frozen crystal clear. I've got some stalactites, the JB weld I put on this pipe. It's holding up quite nicely. This would have been an absolute nightmare to braze that. It wouldn't really stick, I would have had to take it out of the system and take this condenser out and do it upside down, but it's a nightmare. So JD weld's held quite well. Look at the stalactites. Wow. Keeping the drinks cold. Works really well. Quite happy with how the tech repaired this. But now I've sort of know what I'm doing now with refrigeration. R1234ZE and R1234YF you don't need a license for in Australia. HFO refrigerants don't require an Arctic license or EPA certification. Which is good in a way, because there's more on the market now and more options for us other than just using hydrocarbon like HydChill. R1234YF has one thing in common with difluoroethane, is that they both generate hydrogen fluoride gas when they're ignited. So something to watch out for. So this also generates hydrogen fluoride gas. The 1234ZE, HFA 1234ZE, is not flammable, which for us non-Fridgies, and it doesn't have a license, is quite promising. As it's not flammable and it's non-regulated. It can also be bought in Australia in air horns, so if you find any aerosol air horns for sale online or anywhere locally, those there's an 80% chance they'll contain R1234ZE as the propellant. So options are getting more options out there. Anyway, I'm really impressed with how the defrost system in this fridge works. That is a good idea, having a timer like that and a cycle reversing valve. That's a good idea. This fridge here I scored. Had the cord cut off it, but they were just going to throw it out, so I'll take it. They weren't sure if it worked or not, but I took it home and picked it up. I was either going to use it for storage or regas it, but it does work quite well. This is an early in the mid-80s carbonator. With a Tecumseh pancake compressor. I do love those compressors. Earlier ones of these in the late 60s had a slower motor in them. This one here seems to run a bit fast, like the 2850 RPM standard. As you can see, they've got a high side tap there and your low side tap. So just as under those circumstances should methyl chloride be used in this compressor. There was a bit of a board that went behind that and covered all this, so it was insulated for maximum efficiency, but yeah, I do like these Tecumseh compressors. There's a pumps at the top and the motors on the bottom. There's a little fan on the motor, which there's no air in there. I don't know what, that just acts as something to splash oil around, I suppose. This is a copper, I think it's aluminium. No, actually no, it's copper. There's no aluminium in this. Yeah, it's all copper lines, no aluminium. This doesn't have a cycle reversing defrost though. I wonder how this one actually defrosts. But just, yeah, this is a manual defrost. Yeah, manual defrost fridge. But it all works very well. Pretty much got your pipe work running around in there. No fan in there to go wrong like a new fridge. You've got a fan that runs in the freezer compartment and pulls the cold air from the freezer down into here. That is just too problematic. Everything's intact, even the butter container's there. Couldn't let it go to scrap. It's modern, but it's not a piece of junk modern. It's still made in Australia. As I said, it has a good old style compressor. This probably about 5 or 6 or so years shortly after, these models use Panasonic compressors in them. But yeah, it works quite well. Anyway, that'll be enough for now. Thanks for watching.